In this video, we're going to discuss prime numbers. Now, the definition of a prime number is any whole number greater than 1 whose only factors are 1 and itself. So if a prime number has to be greater than 1, let's just take a look at a few. Let's start with 2. So we have 2, and we're going to find the factors of 2. Well, 1 times 2 makes 2, and are there any others? No, there are not. So 1 times 2 are the only factors of 2, so we can say that it is 1 and itself. So we're going to say that 2 is indeed prime. Okay, let's look at 3. 3 is the next one. So we know that 1 times 3 makes 3. And are there any other factors? No, there's not. So 1 times 3 makes 3. So the only factors are 1 and itself. So 3 is also prime. Okay, let's look at the next one, 4. Well, 4 is going to be 1 times 4. And we can also make 2 times 2. So since there are multiple factors here, not just 1 in itself, we're going to say it's composite. So every number, every whole number greater than 1 is either going to be prime or composite. Okay, let's look at a couple more. Let's look at 5. So 5 is 1 times 5. And are there any other factors? No, there are not. So we're going to say 5 is prime. 6 is the next one. We have 1 times 6. We also have 2 times 3 makes 6. So since we have multiple factors, not just 1 and itself, we're going to say that 6 is composite. Okay, 7 is 1 times 7, and there are no other factors, so we're going to say that 7 is prime. Anyway, we could continue this all day long and just go straight down the numbers, but this is the idea. We're going to look for factors other than just 1 in itself, and if there exist factors other than 1 in itself, then the number is going to be composite. However, if 1 and the number are its only factors, we're going to consider it as prime. So let's look at a few more examples. Let's talk about the number 24. So let's take all the factors of 24. We have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Well, automatically, I see that we have more than just 1 and 24, so we know that 24 is going to be composite. Okay, let's look at a number like 31. So, 1 times 31. And what else divides 31? What are other factors of 31? Well, we don't have any more, so 1 and 31 are the only factors of 31, so we can say 1 in itself. So we say that's prime. So that's the idea of running through numbers to see if the number is prime or composite. And again, any prime number is a whole number greater than 1 whose only factors are 1 and itself. Previously, we defined a prime number as any whole number greater than 1 whose only factors are 1 in itself. So right now, I would like to use the Sieve of Eratosthenes to show you kind of a non-traditional way to find all the prime numbers. So as you see on the screen right now, we have every number 1 through 100 on a sheet, and I think probably you can see 1 through 70 right now. So this is how this is going to work. We're going to start with the first prime number, which we know prime numbers have to be greater than 1. So 2 is the first whole number greater than 1. We're going to circle it. And then we're going to take and cross out every multiple of 2. So 4, 6, 8, 10. Basically, we're going to cross out every single even number because all even numbers are multiples of 2. And you'll notice the pattern here. We're just going every other. And let's take it all the way down to, let's say, 50. And we'll just stop at 50. So next, you're going to take the next open number and circle that. And we're going to say that's prime as well. So we're going to say 3 is prime. And now we're going to cross out every third number, so every multiple of 3. So 6, well, that one's crossed out already. 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, and then we can continue past there, but we'll stop for now. You'll notice some of those were crossed out already because we caught them with our 2. So some numbers are divisible by 2 and 3, and those are the ones that when we did the multiples of 3, they happen to have already been crossed out because they were even as well. So let's do the next one. So 5 is our next open number. So let's cross out all the multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So now we've got our multiples of 5. So our next open number is 7. So let's do the multiples of 7. 7, 14, 21, 28, 35, 42, and 49. Okay, continue. That's the end of that row. So let's start over here. We have 11. So let's cross out all the multiples of 11. 11, 22, 33, 44, and that's all the ones up through 50. So 13 is our next open spot. So 13, 26, 39, and 52 is the next one, but we're only going up through 50. So here's 17, so 17, 34, and then 51, but we'll stop right there. So 19, 38, and then the next one's past 50, so we're not going to do that. So it looks like all the things that are left open here, because multiples of 23 are going to be past 50, and 29 is past 50. So it looks like everything else that we have here that we did not cross out, these are all prime numbers. So we have used the Sieve of Eratosthenes to find all the prime numbers less than 50. These prime numbers include 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 primes that are less than 50.